So next comes this concept of balanced and unbalanced circuits. We know that when you have a transmission line, you need two conductors. One is the plus or the minus. Alternatively, as an alternate arrangement, you can have one conductor and another one is the ground. This is also possible. This is also possible. When you have plus and minus, it's called as a balanced transmission line. So a balanced transmission line has a plus and a minus. All the differential signals that you're looking at, that you have studied in the past, which has a plus V and a minus V, those are all balanced transmission line. For example, if the magnetic field is going like that with your right hand, if you were to point your fingers, you see that the current is coming out at you. Here, the current is going in. At any point in time, these two conductors will be carrying current in the opposite directions. So that's a balanced transmission line. It has a plus and it has a minus. An unbalanced one, on the other case, is single-ended. It is single-ended. That means it has a plus which becomes a minus at some other time instant. But while it is a plus, there is nothing as a minus somewhere else. Or while it is a minus, there is nothing called as a plus somewhere else. Instead, it is always either plus or minus with respect to a ground conductor, which is always at 0 volts. So coaxial cable, where you had the inner conductor and the outer conductor, that is a single-ended unbalanced. It is unbalanced. There is no minus to balance the plus, or there is no plus to balance the minus. So coaxial cable, microstrip, strip line, all these are unbalanced transmission line. So when I have two different circuits, one is balanced and other one is unbalanced, how can I go ahead and connect them together? If I want to connect them, what component, what RF component can I use to connect them? You need to use what is called as a balun. A balun is used to connect unbalanced to balanced, or balanced to unbalanced, either way. How does it work? A simple illustration over here for you to see. When I have unbalanced, it is always either plus or minus with respect to a ground which is at 0 volts. It can be represented by this transformer here, which is a center tap transformer. That means you're having a transformer where you're having a primary winding here. So this guy could be the primary winding, which is grounded. This is plus. But on the secondary, you're having a center tap where this guy is grounded, and here you have a plus or a minus. So that at any instant when you have a V0, in the primary, in the secondary, you get a V1 and a V2, that is the EMF induced. So when you have a V0, your V1 and V2 is what appears in the secondary. But notice that whenever V1 is positive, my V2 is negative. So when this is plus V, then this would have been minus V. So at any point in time, this becomes the differential signal. This is plus and this is minus. So when this becomes minus, then this would become plus. They are always opposite in phase, this curve and this curve. Notice that it is 1 over root 2 that of the input. Why 1 over root 2? Because when you square it, it becomes half V0 square. This half is for this port and the other half for the other port. So the power gets split into 2. So that's why the voltage is 1 over root 2. How do you realize this? A nice illustration over here to understand the idea of half wavelength. When you have half wavelength, your beta L is 2 pi over lambda times lambda by 2. So 2 cancels and this becomes 180 degrees, pi or 180 degrees. Exactly this guy and this guy are 180 degree out of phase. So technically I can use a lambda by 2 line to realize 180 degree out of phase signals. How to realize that then? All you have to do is, there is this section that I have. I can transform the impedance as necessary here and split it into two sections. While one section bends off and goes straight, the other section has an additional phase of lambda by 4 plus lambda by 4. So the total difference is going to be lambda by 2 before it comes out. So when this is plus, this is going to be naturally minus because of this additional delay. But that works only at that frequency when this length is, the total length that it travels is lambda by 2. So it's a neat way of finding a balanced, unbalanced transmission line. This is microstrip realization like a printed circuit board, but you can also realize it using circuit components, using lumped components, using L and C. In fact, it's a combination of low pass and high pass. That means once you have a L and a C, you know that this topology is a low pass because this is j omega L, this is 1 over j omega C. At high frequency, it gets shorted down. So this is only low pass, LP. Whereas this guy is high pass, HP. Because high frequency will go through, low frequency will be cut off by this capacitor. So if you use a combination of this plus high pass and combine them like a circuit like this, where this is the low pass chain and this is the high pass chain, if you were to tap the signal out from these 2 points naturally, then I have just a plus and a ground here, you would end up getting differential signals. So this becomes balanced and the input is unbalanced. So this whole device is what you call as a Balun. It helps you to convert balanced to unbalanced. The same thing in transistors, you can realize if you want to have either single-ended or double-ended, balanced or unbalanced. Most of the amplifiers typically have differential inputs. So you would want to have balanced input. Means you will have to introduce this device to convert unbalanced signals to balanced signal while using a differential amplifier. If you want to use a differential, as the name says, it will amplify differential signals.